In the distant past, people were both awed and alarmed by comets, perceiving them as long-haired stars that appeared in the sky unannounced and unpredictably. Chinese astronomers kept extensive records for centuries, including illustrations of characteristic types of comet tails, times of cometary appearances and disappearances, and celestial positions. These historic comet annals have proven to be a valuable resource for later astronomers. We now know that comets are leftovers from the dawn of our solar system around 4.6 billion years ago, and consist mostly of ice coated with dark organic material. They have been referred to as dirty snowballs. They may yield important clues about the formation of our solar system. Comets may have brought water and organic compounds, the building blocks of life, to the early Earth and other parts of the solar system. Where do comets come from? As theorized by astronomer Gerard Kuiper in 1951, a disk-like belt of icy bodies exists beyond Neptune, where a population of dark comets orbits the Sun in the realm of Pluto. These icy objects, occasionally pushed by gravity into orbits bringing them closer to the Sun, become the so-called short-period comets. Taking less than 200 years to orbit the Sun, in many cases their appearance is predictable because they have passed by before. Less predictable are long-period comets, many of which arrive from a region called the Oort cloud about 100,000 astronomical units, that is, about 100,000 times the distance between Earth and the Sun from the Sun. These Oort cloud comets can take as long as 30 million years to complete one trip around the Sun. Each comet has a tiny frozen part, called a nucleus, often no larger than a few kilometers across. The nucleus contains icy chunks, frozen gases with bits of embedded dust. A comet warms up as it nears the Sun and develops an atmosphere, or coma. The Sun's heat causes the comet's ices to change to gases, so the coma gets larger. The coma may extend hundreds of thousands of kilometers. The pressure of sunlight and high-speed solar particles, solar wind, can blow the coma dust and gas away from the Sun, sometimes forming a long, bright tail. Comets actually have two tails, a dust tail and an ion, gaseous tail. Most comets travel a safe distance from the Sun. Comet Halley comes no closer than 89 million kilometers, 55 million miles. However, some comets, called sungrazers, crash straight into the Sun or get so close that they break up and evaporate. Halley's Comet. In 1986, the European spacecraft Giotto became one of the first spacecraft to encounter and photograph the nucleus of a comet, passing and imaging Halley's nucleus as it receded from the Sun. Halley is often called the most famous comet because it marked the first time astronomers understood comets could be repeat visitors to our night skies. Astronomers have now linked the comet's appearances to observations dating back more than 2,000 years. Halley was last seen in Earth's skies in 1986 and was met in space by an international fleet of spacecraft. It will return in 2061 on its regular 76-year journey around the Sun. The history of Halley's Comet. Until the time of English astronomer Edmond Halley, 1656 to 1742, comets were believed to make only one pass through the solar system. But in 1705, Halley used Isaac Newton's theories of gravitation and planetary motions to compute the orbits of several comets. Halley found the similarities in the orbits of bright comets reported in 1531, 1607, and 1682, and he suggested that the trio was actually a single comet making return trips. Halley correctly predicted the comet would return in 1758. History's first known periodic comet was later named in his honor. The comet has since been connected to ancient observations going back more than 2,000 years. It is featured in the famous Bayeux Tapestry, which chronicles the Battle of Hastings in 1066. In 1986, an international fleet spacecraft met the comet for an unprecedented study from a variety of vantage points. The science fleet included Japan's Suisei and Sakigake spacecraft, the Soviet Union's Vega 1 and Vega 2, repurposed after a successful Venus mission, the International ISE-3 spacecraft, and the European Space Agency's Giotto. NASA's Pioneer 7 and Pioneer 12 also contributed to the bounty of science data collected. Halley's connection to meteor showers. Each time Halley returns to the inner solar system, its nucleus sprays ice and rock into space. This debris stream results in two-week meteor showers each year, the Eta Aquariids in May and the Orionids in October. Size. Halley's dimensions are about 9.3 by 5 miles, 15 kilometers by 8 kilometers. It is one of the darkest, or least reflective, objects in the solar system. It has an albedo of 0.03, which means that it reflects only 3% of the light that falls on it. Orbit. Comet Halley moves backward, opposite to Earth's motion, around the Sun in a plane tilted 18 degrees to that of the Earth's orbit. Halley's backward, or retrograde, motion is unusual among short-period comets, as its greatest distance from the Sun, aphelion, is beyond the orbit of Neptune. Halley's orbit period is, on average, 76 Earth years. This corresponds to an orbital circumference around the Sun of about 7.6 billion miles, 12.2 billion kilometers. The period varies from appearance to appearance because of the gravitational effects of the planets. Measured from one perihelion passage to the next, Halley's period has been as short as 74.42 years, 1835 to 1910, and as long as 79.25 years, 451 to 530. The comet's closest approach to Earth occurred in 837 at a distance of 0.033 Australian dollars, 3.07 million miles or 4.94 million kilometers. At that time, April 10, 837, Halley reached a total apparent brightness of about magnitude -3.5, nearly that of Venus at greatest brilliance. The light of Halley was spread over an extended area, however, so its surface brightness was less than that of Venus. During its 1986 appearance, Halley's nearest approach to Earth occurred on the outbound leg of the trip at a distance of 42 cents, 39 million miles or 63 million kilometers. It was slightly brighter than the North Star Polaris but again spread over a much larger area than a point-like star. At aphelion in 1948, Halley was 35 Australian dollars and 25 cents, 3.28 billion miles or 5.27 billion kilometers, from the Sun, well beyond the distance of Neptune. The comet was moving 0.91 kilometers per second, 2,000 miles per hour. At perihelion on February 9, 1986, Halley was only 0.5871 Australian dollars, 87.8 million kilometers, 54.6 million miles, from the Sun, while inside the orbit of Venus. Halley was moving at 122,000 miles per hour, 54.55 kilometers per second. Lifetime. With each orbit around the Sun, a comet the size of Halley loses an estimated 3 to 10 feet, 1 to 3 meters, of material from the surface of its nucleus. Thus, as the comet ages, it eventually dims in appearance and may lose all the ices in its nucleus. The tails disappear at that stage, and the comet finally evolves into a dark mass of rocky material or perhaps dissipates into dust. Scientists calculate that an average periodic comet lives to complete about 1,000 trips around the Sun. Halley has been in its present orbit for at least 16,000 years, but it has shown no obvious signs of aging in its recorded appearances. How this comet got its name. Comets are usually named for their discoverers or for the name of the observatory or telescope used in the discovery. Since Halley correctly predicted the return of this comet, the first such prediction, it is named to honor him. The letter P indicates that Halley is a periodic comet. Periodic comets have an orbital period of less than 200 years. Facts. Length of day: 2.2 Earth days. Length of year: 76.1 Earth years. Diameter: 6.8 miles, 11 kilometers. Comet type: short period, less than 200-year orbit.